Welcome to our Soil Carbon MRV AirMiners event. My name is Jason Grillo with AirMiners. It's great to see you all here today. This is the continuation of our series on monitoring, reporting, and verification. This time talking about soil organic carbon. And to that end, we have a esteemed panel of guests to speak to you today with moderation by Radhika Moolgavkar, who I'll introduce you to in a second. Word and note on why we're doing these. Again, the MRV series came about through audience and community input from AirMiners itself. And people were so interested in the very first one we did, we decided to make that into a whole series of methodology-specific MRV topics to cover the various pathways of carbon removal, because we all agree that MRV is a crucial part of the ecosystem that requires a little bit more attention so that we can put all our entrepreneurial efforts, a good amount of our entrepreneurial efforts into making those solutions a reality. A note on logistics. We're going to have our typical 35-40 minutes of panel discussion today, and then we'll go into Q&A. We'll stop at the top of the hour, and then we'll have about a half an hour of networking. If you want to stick around our Zoom meeting for that point, we will, again, like I said, stop the recording at the top of the hour. Don't feel like you're obligated to stay. We're all busy, but we'd love if you could, so you can get to know each other, not just know of each other. Also to note that if you are in AirMiners, we are going to have a follow-on jam session about soil MRV in 2 days, on Friday, the 30th at 10 a.m. Pacific in the Soil Carbon MRV channel. It'll be a Slack huddle. I'm going to send a message out in AirMiners to that end, so that if you are around and want to just shoot the breeze about things we learned today, can't make the networking session, and want to think about how we can start some new solutions on soil carbon MRV, then we can have that conversation then. Anyway, looking forward to the panel event today. I'll stop right now and leave it to the very able hands of Radhika Moolgavkar. Radhika.
Thanks, Jason. Thanks for organizing the panel and having us all here today. Soil MRV is near and dear to my heart. I've been working on it for 2 years. My name is Radhika Moolgavkar. I work at Nori. We're a carbon removal marketplace, and we launched in U.S. cropland soil 2.5 years ago, I think is when we launched our methodology. So we've been diving into verification for a long time. We also have our esteemed panel, and I will let them introduce themselves. So Jenette, can you take it away?
Absolutely. Hi, and thank you for having me. It's awesome to be with my fellow AirMiners. My name is Jenette Ashtekar. I head product management at CIBO Technologies. We're a science-based software company, and I'm a soil scientist by training. So great to see y'all today.
Aadith?
Yeah, thanks for having me. I'm Aadith Moorthy. I'm the founder and CEO of Boomitra, where we work internationally across 4 continents and about 5 million or so acres, helping farmers to increase soil carbon and turning it into a third-party certified carbon removal credits. And we also have our own MRV piece in that, using satellites and AI to measure soil carbon. And I'm excited to be with you today and to hear all of your questions.
Chris?
Hey, I'm Chris. I'm the CEO of Yardstick. We measure soil carbon proximally. So we do stuff in field on the farm with spectroscopy. Basically means fancy video camera. I'm not a soil scientist by background. I'm a furniture maker by background. So everything I have to say today, I'm just repeating what I've heard from people who actually know what they're talking about.
Chris, I'm sure you know more than you're letting on, but as you can tell, we have a pretty diverse and interesting panel. So I'm going to get started with Jenette, who is a soil scientist, to kind of just provide an overview of soil science MRV in the current marketplace, why it's important, which I think most of us know, but always good to rehear, and do many people consider soil sampling kind of the gold standard?
Absolutely. Yeah, thank you. And it's a phenomenal question. And I should add that CIBO, the company I work with, makes software that supports MRV and soil carbon and agricultural systems, and also helping with growers and farmers actually getting enrolled into these type of programs. And this is a question that comes up constantly of how are we verifying, how do we know that the carbon in an offsetting situation is actually in the soil and we paid for it? It's a fungible resource, which I'm sure Radhika is familiar with, thinking about cryptocurrency. And that's where MRV really comes in. So we need to be able to verify credibly that the carbon somebody is paying for as an offset or a removal or a reduction is actually there, or it's in the soil. And today, the way that is done at the most gold standard level is through soil sampling. So the idea with soil carbon markets is that you do a new agricultural practice and it increases the accumulation of carbon within the soil. And that carbon is stored inside the soil, potentially, permanently if it's managed correctly. And so in order to monetize that, we need to actually be able to demonstrate over a specific time period, here's a starting soil carbon, here's an ending soil carbon, and the difference between start and end is the offset, is the actual, drawdown or sequestration that has occurred. And so in order to verify this, we absolutely have to sample. And so when you look at major carbon credit registries like Verra, soil sampling is a requirement. Soil sampling is also expensive and restrictive. And it takes years for soil carbon to materialize. So if I start a practice today, I might not see changes in soil carbon accumulation that I can detect with the type of laboratory analysis that is run on a sample. I might not be able to detect that carbon change for years, 5 years, up to 5 years. And so because we can't wait 5 years sometimes to mint a credit or to sell a credit or to make a payment to the farmer who's supplying the offset, we are now starting to use modeling to be able to understand annual sequestration of carbon. So ultimately, we need to sample at the beginning of a monitoring period and at the end of a monitoring period to show, with ground truth sample data that's been run through a lab, how much organic carbon has accumulated. And between the start point and the end point of our sampling, we can use models. We can use mechanistic biogeochemical models that enable us to model the annual accumulation of carbon. And so through registries like Verra, we can actually use the model to predict how much carbon we think will occur annually so that we can issue credits on an annual basis and then use the sampling at the end of a monitoring period as a true up. So if I modeled too much carbon, then when I finally sample, I draw from my buffer pool. If I modeled too little carbon, when I finally sample, I actually give money back. I give more credits. So sampling really important, very expensive, and we are mixing it with modeling to be able to come up with more incremental verification and measurement of carbon.
So Chris, I'm going to turn it over to you because Yardstick is taking a new or maybe a supplemental approach to current soil MRV. Can you briefly describe your company's technology and your thoughts about our MRV and the challenges you're hoping to address?
Yep. So Jenette described how sampling is important but hard and expensive, and how modeling is a complement to that. Rather than develop technologies which are complementary at a different scale, modeling is sort of an ability to predict changes with basically computers, if-then statements. And remote sensing data is trying to look at landscapes with satellite imagery or other kind of, airborne-based imagery. We're trying to directly replace direct sampling itself. Our technology is in situ spectroscopy. In situ means it's on the farm. It's not in a lab because you can do spectroscopy anywhere. And then spectroscopy, as I mentioned, means fancy video camera. If I walked around a zoo with a smartphone and took a video, and then I said, hey, Radhika, watch the video and point to the giraffe, eventually you'd be like, aha, I'm at minute 47. There's the giraffe. Our software knows what the shape of soil carbon is in spectroscopy. I can share a video a little later if folks are curious, but basically looks like a giant hand drill. We're trying to still maintain the primacy of boots on the ground, touching the soil, especially consideration of depth, just trying to do so with a technology that eliminates removing the physical soil sample from the ground, which is a pain in the ass, therefore error prone and expensive, and sending that sample to a lab, which could be a long way away, annoying, therefore expensive, as well as the equipment at the lab itself is expensive. Those three things stack up, equals conventional sampling is prohibitively costly. We're trying to do the exact same thing, generate point data on the farm, in the field, but do so at a much lower cost basis on sort of a per sample site consideration.
And Chris, as a follow-on question, does your technology need the number of soil samples that a rigorous soil sampling and testing stratification would, or is it in the same ballpark?
It needs more. Yeah, so we will likely be less accurate on a per sample site basis. Most is a squirrely word, but most interrogation of soil carbon stock changes today care most about the stocks, not point data. So, I'm looking at my dining room table here. I don't care about the 3 points on it. I care about the profile of the whole table. It's an area calculation, and then a depth calculation gives us volume. In that volume, what's the mass of organic carbon we're looking at? That means that I kind of don't care, is that individual point right, as long as the stock is right, is precise. This gets into a whole bunch of spatial statistics that are hard to explain in a 1-minute answer, but essentially we are conceding that our technology will be less accurate on a per sample site basis, and we compensate with greater than conventional density. And those are proportional. So the less accurate we are at each individual site, the greater we need to jack up density to be able to see the true mean through it. And what that also means is that yardstick will not be a good alternative for folks who want point level precision. This is not precision agriculture. I'm not trying to say, ooh, the northeast corner is high carbon and the southwest corner is low carbon. I can't describe different parts of the field at all, typically. But for the purpose of many soil carbon market methodologies, that doesn't matter because I don't need that level of detail. So that's a long way of saying it. Less accurate, a lot more sample sites, but because the marginal cost of each sample site is so cheap, hell yeah, add a whole bunch of sites and the overall cost is still much lower.
Oh, cool. Very cool. Thank you. Aadith, your company is going in a slightly different direction. You guys are using AI and satellites, which Chris briefly touched upon. You're also looking to do carbon projects around the world. So knowing, measuring soil carbon is tricky, as we've kind of heard the other two describe. How does your technology help move carbon measurements along and also help open it up to the rest of the world?
My apologies, I was muted for a few seconds there, I just realized. Yeah, so thanks Radhika for the excellent question. Actually, I also think that Chris did a really good job with the analogies that he was throwing out there. And it's kind of similar in a way to the same analogies that I would say too, but I won't bore you with those. But at a high level, as you mentioned, we use satellites along with AI to convert what those satellites see into actionable numbers on the ground and within the soil. The methodologies of the actual science behind how it works is slightly different than how, for example, Chris's yardstick science works. But the analogy of how you connect what these devices, be it satellites or sensors, are measuring and converting that into actual information on the ground, it's kind of similar. And at the end of the day, we are always using we do have to calibrate our systems for a given geography when we enter into a geography with the real ground truth, gold standard soil samples that are taken in a methodological way. But once the ground truthing is done for an entire region, then we can deploy quite smoothly. And as was alluded to earlier in this discussion, these kinds of technologies, and in particular satellite technology like what we are developing, we are able to see to a 10-meter resolution in many geographies and 30-meter resolution in some other geographies. And with that level of resolution, that enables us to see variations that occur on that level and enables us to really, on a project level, achieve very, very good results, because for every acre, we might have like a 40 measurements, or and it scales like that. In our projects, for example, our largest project has like 1.8 million acres. And when you're at that level, then the amount of measurements is also commensurately way, way, way larger. That's actually taken into account. And then there's also the element of time that we're able to see the trend of the soil carbon with time. And there's a seasonality to soil carbon as well. Factoring in that seasonality factoring in those changes that are present within a field itself. If you go and read precision agriculture literature, they'll tell you that the soil carbon changes every few acres. It's so erratic that it's very, very hard to get right.
Inches,
For that
every
reason.
few inches, I would say.
Yeah, yes, yeah. Every few inches is how it actually changes. But when you go to a land grant university and ask what is my sampling protocol, they'd say you can't sample every few inches. It's okay if you sample every few acres, is what they will say. So, but even sampling every few acres is too much sampling for doing things on scale of millions of acres. And then you talk about how would right now a lot of the focus on soil carbon is simply on a significant amount of focus is on doing it in the United States or in Australia or in Europe. But then if you think about the majority of farmers in the world, like 99% of farmers in the world are actually small farmers. And there's farmers that are that have like 1 acre of land. There's farmers with half-acre land. We work with those farmers. We work with 100,000 plus farmers worldwide. And of course, the large percentage of that number ends up with small farmers because small farmers add to the numbers, large farmers add to the total acres that we work on. So we work with both this very small 1 acre farmers and also 100,000 acre large ranch in the Americas, for example. So we work across all of those sizes, and having the technology to do that, of using remote sensing to see things to a 10-meter resolution, and then have a properly calibrated system that we're able to take through a third-party audit that allows us to use remote sensing in that way, allows us to work in a very inclusive manner, because we don't want to exclude folks operating on 1 acre, half acre, while at the same time we want to provide something that can scale to the needs of soil carbon projects all around the world. And the kind of technology that we are building unlocks that and enables us to work across that horizon and across various different sizes.
I really love your focus on both small and large scale farmers. That's something Nori also is very interested in. So I applaud that in particular, though everything you're talking about sounds very interesting. So Aadith and Chris, you both are startups. You're both kind of breaking into a world of old school registries. So I am wondering how you both work with farmers and the various registries and marketplaces to accept your technologies. And as a side note, would your product scale outside of soil carbon? And I'll start with you, Aadith, and go to Chris next.
Yeah, so I can handle the first part, but I love for you to later clarify what you mean by product scale outside of soil carbon. I didn't quite understand what you. Are you muted, or we cannot hear
just
you?
Other types of carbon removal technologies, like other types of forest, that kind of thing.
Okay. Yeah. So right now, actually, we tend to work primarily with international registries. We're not creating our own registry, internationally recognized registry. So if you go to, for example, the Vera registry right now, I invite everyone, you can go and type in Boomitra into the search bar and see some of our more advanced projects. We have way more nascent projects that are not listed or not even started validation or anything. But you can go there and you can check out some of our projects, and some and they're all in various stages. And there are some that have gone through most of third-party validation. There are some that are starting out third-party validation. There's a variety of different areas in which the projects are globally, and we primarily, as you probably guessed, then we work with the Vera standards. And the great thing is that with the latest Vera standards, we're able to not only measure the project, but also the baseline conditions using our technology, and turn that into actual credits after we successfully convince the third-party auditor with all of the ground truth data that we have that our calibrated system works. So that is our process. That we have to first. We do have a lot of work to convince a third-party auditor, and every single project that we do in a different region of the world, we do have to work with the third-party auditor to convince them that the ground truth data matches satellite information. But that is the key validation that needs to be done on the technology side, and with actual ground truth data. So that is something that we do on every single project level. And then, of course, we are in our world, we are also sort of the soil carbon project developers. So we have our own projects, and then we are selling the credits out of those projects as well. And so far, the uptake from the clients who want to buy these credits from us has been very, very good. We have tens of millions of dollars in contracts with clients who
And
want
Aadith,
these credits.
I would ask though, just because there's a lot
Yeah.
of people in the carbon community here, when we're saying all these credits I'm selling, do you have any minted credits, actual credits, or you're talking more theoretical credits one day on a theoretical project that could be approved?
Okay, so there are the projects that we have gotten through most of validation with the third-party audits and are having issuances coming up soon. So in the soil carbon world, most projects out there have not gone through the issuance stage because many methodologies are new and many systems are new. So when I talk about having soil credits, it implies either prepayments for credits that are to be delivered within coming months, or it means forward contracts for credits that will be delivered in the coming months. Nothing further than that, into the future.
Yeah. And I think that's important for this community to understand is that this whole soil carbon thing is not real yet. There's been like 20,000 tons issued across the entire industry. CIBO Technologies has the first project that's under verification in the Vera pipeline for credits in the US. And we've done a full model validation report, incredible amounts of work. And we've done monitoring and blah, blah, blah. And right now, everything is kind of on hold because Vera has to process all of these different projects that you're hearing.
And I might add there that Boomitra has the first project with the same methodology that CIBO uses that was actually sent for third-party verification, but not in the US.
So
international though.
I would love to get Chris's perspective on it and hear what Yardstick is doing in terms of working with the registries. And if you don't mind, Chris.
I don't. So right now, most of the leading soil carbon market methodologies say, hey, it's got to be labs because they know like other people are working on other stuff. And that's fine. So that means that our work is to convince them of the same thing that we intend to convince like anybody else of, which is like, hey, no, we got another thing that's compelling. Very few of the registries have sufficient permanent staff that has the technical knowledge to like actually evaluate the claims we would make about spectroscopy versus labs. They would acknowledge that. That's why they have like technical advisory panels anytime they're developing new methodologies. So it's kind of awkward because it's like, hey, Car, I'm going to convince you of something in the future. And they're like, can't wait. But like, when you do, tell me beforehand so I can have like the right people in the room. So one piece of it is with the registry itself, but more importantly for us is doing that same like consensus building with the folks that we know they're going to call when it comes to that. A lot of the criticisms of like nepotism and sort of like, are there truly independent perspectives within a lot of the registries and methodology development are very fair, even as like, I don't see a lot of really high quality alternative systems. So that means, of like 100% of, outside the company consensus building effort, we probably put 25% of it on the registries, 60% of it on the soil science community, whom they would rely on, and then like 15% of it on the buyers of these tons, who are a quite short list of folks who have their own relatively independent technical sophistication. And that tends to be like the Microsofts who have basically like spent a lot of money on Carbon Direct to like get smart about soil carbon. Or in contrast, the Stripes of the world who are like, miss me with the soil carbon, but that means they actually have like pretty well-informed opinions about it. We would not expect Stripe to like turn around and be like, JK, we're going to buy a whole bunch of soil carbon tons. But it means as someone who's critical of nature-based solutions in general, if we can show up with some evidence of like, hey, we're actually addressing concerns around permanence or reversibility, that kind of bodes well for us, our ability to make the same case with folks who are kind of more confidently in the nature-based systems world. But the registry itself, I think, is not minor, but is way less centrally significant than in our experience many people would perceive from the outside, especially because a whole bunch of transacting happens like off registry. Like there's you can sell soil carbon tons that don't have any CAR or Vera blessing, and that cuts both ways. Like our worldview in general is that the existing registries are necessary but insufficient. We like broadly support off registry work so long as it's disclosed in sufficient detail that you can actually figure out what the hell is going on, because that's rare. There's a lot of like, we sold a whole bunch of tons, but like, I'm not going to explain them to you. And that's obviously not good for anybody.
So Chris, what about the farmers? You didn't mention them. So how are they adopting your technology and their willingness to have you come onto their land?
Yeah, so we don't engage directly with them substantially because our customers are project developers or folks who are acting as a project developer. Like the two flavors are basically the Indigos of the world who are trying to sell tons, or the Organic Valleys of the world who are trying to develop their own tons within their own supply chains that they kind of eat themselves rather than retail. So the only convincing of farmers and ranchers we have to do are folks who have already sold on existing programs from these intermediaries, which means it's like an email intro or a text intro of a project developer saying like, hey, you know, Farmer Amy, like Yardstick's going to be there on Tuesday. Like, don't give them a hard time. Like, they're with me. But that's consistent with many farmers and ranchers' experience anyway, because most project developers are subcontracting sampling services anyway. And generally, I mean, foolish to generalize about massive groups of people with incredible diversity, but generally speaking, like farmers don't want to sample their own soils anyway. Like they're busy farming. They often hire an agronomist to give them nutrition advice, do sampling for nutrition before they develop a fertilizer plan. So it's generally uncontroversial to them that there's a third party like Yardstick who's showing up, who's different from the Indigo or the Organic Valley. And I'd say just one corner case is there are, of course, early adopters within farmer and rancher communities who just personality wise are like, hell yeah, I want to be part of something new. And they tend to hit us up direct, and we do R&D work with them, but we're typically not quantifying stocks for the purpose of existing carbon programs. So it's a little more ad hoc, where we basically say, hey, if you'll give me access to your land, I'll spend a shit ton of money on labs, and then, hey, you'll get all that data. But to be clear, you know, this isn't a baseline that'll pass muster with a CAR SCP or Vera VM42 sort of thing.
All right. So Jenette, as you've been in soil carbon for a long time, as has Nori, we've actually sold like 100 and some thousand tons of carbon, but you have been working on scaling this and adoption of regenerative ag and soil carbon sequestration in the voluntary market. So currently, what do you see as the biggest challenge in soil MRV? And, you know, with all of the attention and money, have you seen an acceleration to solving some of these problems?
Great. Yeah, great question. Thank you. And that's a great point. Nori has sold tons and tons of carbon. CIBO has sold quite a bit of carbon too in our own registry worlds. And it's hard to believe, but you can actually provide very high quality projects without having to go through a registry if you're willing to just build a high quality project and get some third parties in there to verify it. So, you know, that's a path that's another conversation we should all be having. But yeah, in terms of like what's really holding back MRV, in my opinion, in soil carbon is the sampling, like what we've been talking about. It's actually having to go out and sample and verify that it's there, and the cost associated with that sampling. And the technologies we're hearing about, like Yardstick and Aadith's technology around, you know, maybe one day being able to use satellite imagery to understand soil carbon. Those things are models. And those models require lots and lots and lots of samples. And so really going out there, sampling, accumulating that library is a limiter. And then, you know, similarly, around that is uncertainty. So carbon credits are supposed to be a fungible asset. We know they're there. There is an enormous amount of uncertainty in agricultural systems and environmental systems, and that cannot change, period. It doesn't matter how good our detection is. There is enormous amount of uncertainty in weather patterns, things that are occurring year over year, and those will never change. And so until the industry becomes comfortable with the fact that there is underlying stochasticity in our universe that we can't do anything about, and chaos that causes uncertainty that propagates throughout these environmental systems, you know, until we can eat that and understand that, we're not really going to be able to scale this, because we're going to have to keep relying on, you know, go out and do more samples until we reduce the uncertainty. But, you know, we can only sample so much. We're going to have to get comfortable with uncertainty. And then, you know, on this sampling side, understanding that going out there, sampling is very expensive, difficult, and it's required for all of these new technologies that are emerging. They need hundreds of thousands of samples really to do this well at scale. and build these models. Like all of our companies are out here separately collecting these samples. Every company on this call today, we're spending shitloads of money on sampling, and we're not sharing any of it. And we're sampling the same farmers' fields and the same soils. So, there's progress being made. The gentlemen I'm here in the call with today are making some of that progress, but we're all still going to be limited by this sampling problem. And probably no individual company is going to solve that on their own, we'll run out of VC dollars before then. So sampling, collaboration will help get us there.
To add on actually very briefly to Janet's point, this is literally what we also see in the rest of the world is that through the work of, so we have a huge partner network globally, and that partner network has been really beneficial to us in building up our own soil carbon data, of ground truth data for calibrating these systems. And in some places, for example, in individual states, in some countries, we have millions of soil samples, and that is only possible through our partner network. So again, echoing what Jenette is saying, yes, having people work together to kind of bring all this together might be a key thing in not just in the United States, but all around the world for having the right amount of data to make progress.
Yep. And I will add to that point, like my background is in digital soil mapping. So literally using data sets, ground truth data, and, math and algorithms and remote sensing to predict soil carbon at different scales, which is, very, this big problem. And the advancement that has made over the last 20 years is significant. And I will tell you that the advancement that's probably occurring right now is exponential relative to the last 20 years because of all of this interest and investment. The people going out there and accumulating these data sets. And so it's a problem, it's a challenge, but it's also solvable. Like if it's a data limiting problem and we know what the data is, great, we can eliminate the problem. But the uncertainty won't go away. We can't fix weather.
Right. Yeah. Right. You can't create a perfect nature-based system. Chris, congrats to Yardstick, because you guys have just been announced some pretty cool funding. Some of it is from the USDA. And so how do you think about the impact of government policy in this space, I guess, specific to the US? And are there areas that you think the US government or the USDA could be most impactful?
Yeah, I think do not mistake me for someone who understands how policy works. I think I am good at applying for grants when there is the opportunity to get free money. And that can look like we know what we're doing in this domain, but I definitely won't overstate my own expertise there. For most of that, honestly, we rely on friends who actually understand the policy landscape way better than us. We're very close with the Soil Health Institute, which has a whole bunch of ex-USDA people, and they do a lot of grant work with NRCS and similar. Carbon 180 is an amazing organization for carbon removal generally. So what we mostly do is try and pay attention to the folks who are identifying measurement as a problem that would precede real climate impact. And I don't feel like I've had material success in figuring out how to drive that conversation so much as have enough friends that are paying attention such that when that question gets raised, we're sort of like, oh, hey. I will say, though, that I've been surprised at how effective it is to just literally email a random ass USDA person and be like, hey, like, we're working on this thing. I think I've always had rightly or wrongly, this perception of a lot of policy stuff as being like, ooh, like independence from the market. And it's not that. They're actually like, you are working on the problem we care about. They're not just going to like do what I say, right? Like they want to see the evidence same as anybody else does. But we've like cold emailed some like senators' offices and had success. We've cold emailed some USDA and NRCS people and had success. Obviously, IRA includes some interesting provisions, this like 20 billion for climate smart agriculture. That looks like it'll largely be extension of existing programs like CRP or EQIP. But then there's this 300 million for like soil sampling to understand soil carbon sequestration. And I'm like, that's what I do. Like, how will that shake out? So yeah, mostly what happens then is I like see that and then I email people who actually know what they're doing. And I'm like, how can I get some of that money? And then eventually someone like points me in the right direction. But I actually won't pretend to have something much more sophisticated to provide than that.
All right, well, final question before we open it up to our audience, and this is for all of you. I'll start with Aadith, which is, where do you see soil MRV heading in the next 5 years? And what is the most important issue that needs to be addressed to continue growing the market?
Yeah, interestingly, all of us on the panel come from quite a bit of diversity here. So many of these things have actually been covered by some of the people already speaking here so far. But yeah, so where do we see it going in the next 5 years? Of course, the continuous price decrease, endless price decrease until suddenly the MRV. See, technically, when you think about a carbon credit, one of our key values at Boomitra, which I think is also important for the market as a whole, is that the majority of the carbon credit should be heading to the farmer. Today, actually, in certain scenarios, I have observed, not necessarily in any Boomitra scenarios, but in some scenarios, I've observed that it's less than half of the credit that's going to the farmer because so much is just consumed with spending on trying to measure what is going on. And that kind of is a problem because the whole point of these markets are supposed to be to incentivize the carbon sequestration process itself. And it's not supposed, the measurement is not supposed to be the majority of the cost. But we will see that coming down. We're already seeing that coming down. And already in our systems, for example, the marginal cost of adding an additional farmer to the program is very, very minimal from the measurement perspective for us. So like that, we will continue to see lots of improvements in cost, just like how we've seen, for example, with solar cells and batteries in the past decade, huge decreases in cost that those observed. Technologies in carbon removal, particularly even including in soil carbon removal MRV, I think we will see something quite similar to that. Beyond that, there will also be more and more soil carbon data available from different places around the world, not just private companies' data, but even there are many governments undertaking this on a huge level in different parts of the world to do a large amount of soil carbon surveying. And all of that is huge amounts of ground truth data for properly doing these kinds of activities and building out the proper systems that's necessary. And last but not least, from our perspective, from the satellite perspective, there's even more satellites launching into space with all sorts of new capabilities. There have been quite a few good satellites that have been delayed from being launched in 21 and 2022, but we will see them launched in the next 5 years. And those satellite capabilities will also enhance our ability to see deeper into the soil. Like, for example, right now, we only do we generally stick to 30 centimeter to 40 centimeter, that kind of a depth horizon. But we will be expanding that at Boomitra itself to 60, 70, even 1 meter with the availability of better and better satellite data and better satellites and different satellites that are being launched into space. So all of those things, there's going to be a watershed, and soil carbon MRV itself will become way more cost effective. So that what I hope for, is that one day, like maybe 5 years or 6, 7 years from now, we should even be able to help the small farmer in Chad. Chad is a country in the central part of Africa, which is considered one of the least developed countries in the world. And it's really, really hard for anyone to work there. But the whole idea of climate action should be that we bring climate action to every single farmer out there, not just to a few farmers, but every single farmer, every single landowner should be able to work together to not only fight back against climate change, but adapt themselves and mitigate. So that is our goal at Boomitra, and the trajectories of the technology world are heading in that direction.
Well, with that uplifting note of hopefully moving across the world, I'm actually going to turn it over to audience questions because we have less than 20 minutes and I can see a whole bunch in the chat. So Jason.
Sure. Gina Nichols, you had a question to ask, so feel free to unmute yourself and ask away.
Yeah,
hey, Gina.
Thanks, Jason. I did see there were some replies in the chat, and I am curious to hear. So I think a lot about what is pre-competitive and what is embodied in the competitive scene. And I personally think that these calibration data sets should be pre-competitive, because right now it's who can throw the most money at it and get the biggest calibration data set. And I don't think, the rising tide lifts all boats. And so to me, I feel like there should be a universal, publicly available, really solid soil carbon calibration data set. And I see that there are some folks working on that. It looks like it's citizen science driven, and I don't know if the producers are being compensated for the data that they're providing. So I would just love to hear this group's take on that idea.
Yeah, you're preaching to the choir. Like, this has been across, and Chris talked about, lobbying our government. This is what everybody in our industry has been saying, is we need a common calibration validation set. We each have different models that are telling you how much carbon is in your offset. And they each have different results, and they each have different uncertainties. And those uncertainties were assessed using totally different data sets by different scientists. And there's no solve for that right now. So we need a common data set. We have a great data set at CIBO, right? We'd love to make it public, but what happens when you spend $1 million of IP generating that data set and your competitors? Because in this industry, agriculture is extremely consolidated and competitive, and it's very ugly when you get outside of our friendly sustainability people. And it's a very, very huge issue. Apparently the US government has heard us though. And they, as Chris mentioned, are thinking about how do we actually develop and enable this publicly available data set and host it. But yeah, you first. Who among us will give up their IP first?
Yeah, I won't. But yeah, Gina, I also want that. I also want like single payer healthcare, and like I also want like a pony. Like, there's a whole bunch of things about like capitalism that make shit like hard to do, even when it's obviously the good thing. And so basically, like, tell the USDA to give me $300 million, and yeah, like I'll go do that. And I don't care that it's available, because if I have $300 million of revenue, I don't have to raise money next year, which would be great. I think there also are, though, like deeper structural challenges to what otherwise seems like an obviously good idea. One is land is a real asset, and I'm going to wildly oversimplify that. Like, low organic carbon content is likely to be a predictor of lower performance over the long term, lower climate resistance, lower yields. So like, would you let somebody put a webcam in your basement and then have that up on Zillow so we can see like how often it really floods? Like, probably not.
Well, in the Midwest, they have the corn suitability rating, which is tied to your real estate values. And so I think there is precedence for that, but that is a good point.
Yeah, and to be clear, I'm not saying anything is impossible. I'm just saying when you start to dig into the details of the barriers, a lot of them are like pretty hairy. I would strongly recommend everybody look up this amazing researcher, Kathy Todd Brown, who's done a lot around privacy and farmer data. Because remember, for the sake of simplicity on this conversation, we've talked about measuring soil carbon as, at this point, here is the organic carbon concentration. But especially CIBO does a ton of stuff with management practice data. That's like incredibly sensitive information. Water use data, like spoiler alert, like a lot of farmers break the law by using too much water. And all of a sudden we're like, let's just see how much water everybody uses. And they're like, no, I don't want to go to prison. Like, there's a lot of good reasons why they wouldn't want to
farmers are taxed based on self-reported yields. So there's a lot of fear and skepticism of the government understanding what you're doing or your survey data. And just because we're all here, we're going after soil carbon markets in agriculture. I bet everybody, who's on this call, who's a part of it, because we care about the betterment of our agricultural systems, and growing carbon enables us to thrive under our new climate reality. You hold on to water in a drought, you release water in a flood. And so we're talking about carbon offsets at CIBO because it's a means to an end, and it's injecting capital into our ag system so they could do the right thing, and we can produce food when we get to 1.5 degrees. Just to be direct here. So yeah.
And I think a great analogy is like privacy and data aggregation in healthcare. Like, the challenge is spatial data is inseparable from place. Like, you can anonymize your blood pressure. You can put age, weight, race, and still generally not know who you're talking about, because there are 300 million people that can get sliced a whole bunch of different ways in America. You can't separate this data from place, which means there is no such thing as anonymity. And that's also where, thank you, Jason, for the link to Kathy. Like, Kathy has done some really interesting work around like relative anonymization. You know, what if, you know, imagine the spatial data we had was only accurate to a quarter kilometer in any direction. Would it be as valuable? Would it be valuable enough? There's this slider between like precision and privacy that's just really, really hairy. And to be clear, all of Yardstick's customers, even if I've spent money for my own probe R&D, all of my customers are themselves private entities who like don't give a shit about like the commons. So all that to say, I am like 100% hell yes, Gina, and 100% like, wow, there are some hairy barriers here that I don't pretend to have solutions for.
I appreciate what you know, your point around like, you know, the people not wanting to share data and being afraid of it. And it's at the producer, the farmer level, and those who work with the farmers and collect that data. We, you know, our platform essentially host carbon offsetting and insetting and emission reduction programs for all different companies. And it's like a white labeled solution, right? And so we're doing this across, you know, all of these different groups. And even those companies are using our software to collect data from their farmer customers. And they say, I want my data for my customers to make my thing better, but you better make sure that on AWS, it's segmented and doesn't touch your other customers, because I don't want their stuff to be better, right? And so it's competitive at the farmer level, it's competitive at those who touch farmers, and then our government is also highly, they're highly protective of farmer data as well.
This is a great question, but I think Jason wants to move on to another one because we spent a lot of time on it. We have a bunch of questions. So Jason, who's next?
Yeah, real quickly, Crystal, are you able to unmute and ask your question?
Yeah, sure. Hi, everyone. Hey, Chris. So my question is, it feels like this conversation is very much around the benefits of MRV to improve accuracy of soil carbon monitoring so that we can create offset credits that are more reliable and that, you know, different companies feel more comfortable purchasing. I guess I'm wondering, what is the benefit of soil carbon MRV if offset markets did not exist? Like, what are other uses for soil carbon MRV? Like, if we didn't have offset credits.
Yeah, I think there are a
Great
lot
question.
of, yeah, it's a wonderful question, right? Because we're already starting to see the segmentation in the market right now. So even if we didn't have offsets, we might still have insets. And there are programs where there are companies that are trying to green their own supply chain. And there's the scope 3 emissions of the food companies where they're trying to grow the food with less emissions. We would still have that even without offset markets because we want to all head towards decarbonization. And the big food companies of the world still need proper soil carbon MRV so that they can actually measure what is the carbon intensity of this beef that I'm selling to you, or whatever is the case. So that's still a necessity that we have. And beyond that, also there's the advisory aspect of the farmers, because this actually enables us to provide better fertilizer recommendations to the farmers. So that's an original business that Boomitra used to be in before we started all this carbon stuff. So there's the idea that if you have the better soil carbon, we know it's there and we can see what level is, you can tailor the fertilizer application appropriately. If you know the soil carbon level and the soil nitrogen level, tailor the excess nitrogen that you're applying appropriately. So there's both of those in our opinion. I know Jenette is very easy to
I have to say like that I actually disagree. I think, you know, just from the recommendation perspective of, I really think that, you know, and what you're describing insetting, very similar to offsetting, right? We want to measure the amount of carbon in the soil because we're monetizing the value of that carbon sequestration. And like outside of that use case where we need to get extremely accurate, precise, because we need to know the carbon because someone's paying dollars for it. Outside of that, I do not see an extreme need for this level of accuracy and precision, because when I make a nitrogen recommendation, it doesn't matter if it's 3.2 or 3.21. That's not, I'm still going to make a similar nitrogen recommendation. And so I have been, I think it's amazing that all of this money is coming into soil carbon. I think it's wonderful, and regenerative agriculture, and we're growing these models, and it's ultimately phenomenal. But starting to think about new use cases of where having that level of precision and accuracy actually gets us something meaningful outside of monetizing. We're basically monetizing the fact that we were able to accurately measure the carbon. That's what we're selling. We're selling the measurement and the verification of that. So outside of that monetization of the carbon, I would love, to see more, or beyond making a nitrogen recommendation, like more evolving use cases for this incredible technology, because it's so expensive to build. Let's hope that there's more use for it.
Yeah, I strongly agree, especially the point about precision, because this is not a binary question of like, are you measuring something or are you not measuring something? The bulk of cost is proportional to the precision you need. And when you need to see a very small signal to noise, you have to spend a lot to see it. You're only going to spend that much if there's a clear economic driver of that precision itself. And I don't see there are that many other places besides carbon markets right now. That doesn't mean that this isn't valuable work economically in other ways, but it just means that the precision requirements for these different applications are completely different. The only other thing I would point to that's encouraging to me is there are precious few long-term players, one of whom would be insurance, like better risk modeling. I think could different precision requirements, but basically understanding like what is land, which is more likely to be more resilient, especially in kind of the face of changing climate and weather. And then the other is like property hedge funds, like farmland hedge funds. And like, I don't get excited about like helping those people do their job, but who has an incentive to like actually know like what's going to be the good stuff of the future is another thing that comes up for me. And otherwise, I hear all the time from, again, our key scientific collaborators, this organization, the Soil Health Institute, and they always remind us, they're like, we're the Soil Health Institute, not the Soil Carbon Institute, for a reason. And thankfully, carbon values are highly predictive in many instances of overall soil health, but there's a lot between here and there that is very, very immature.
Thank you all. That was super helpful. And I think, the question is arising from what level of precision do we need for what different uses of MRV? And I think it's important to continuously make the case for why soil carbon MRV is important beyond just the immediate opportunity of, offset markets really taking off in the ag space.
Yeah, especially because when you actually like look at it, the absolute dollars in voluntary markets are like not big enough to support all of this investment. Like it feels big because Indigo is really good at marketing, but it is just like insignificant dollar wise. Like I do not recommend showing your investors the total addressable market of voluntary soil carbon offsets in America when you're trying to raise money. It's
completely insustainable when you look at the cost. So our project on Vera, when you talk about a per ton cost, I won't tell you out loud, but it's completely insustainable. And there's actually no way when you look at it to make it scalable without getting mass grower adoption. And that's kind of the big thing we're not talking about here, which is like the real blocker to this whole thing is a farmer has to sign a contract and then make a life-altering decision to change the fundamental part of their business, which is how they operate, which is their cropping rotation. So another conversation.
So we have 5 minutes and maybe Jason can get one more question in, huh?
Yeah, well, one last question. AirMiners, we're all very entrepreneurial types here. If you were starting off a soil carbon MRV company from the very start, from its very beginning, what advice would you have to that entrepreneurial person? Again, many people who are interested in getting into this space, lots of opportunity. What advice would you have for people watching who are on that pathway?
Don't, it's overcrowded. I'd wait a little bit for it to calm down.
Yeah,
Let's
don't.
see how it's short. Let's see how it shakes out. Don't join. No, I mean, really, but my one advice would be, and it brings up with the last question, like, so what? Like, okay, great. What is your use case that goes beyond the soil carbon offset market? What soils and what nobody, and being a soil scientist working on mapping for years, nobody cares about your soil unless it relates to something else that drives dollars. So what's the so what, and lead with that.
Yeah. And especially the so what I'd encourage is, as we've talked about, beyond carbon markets. Like since the beginning of time of Yardstick, people are like, oh, can you also do nutrition? And we're like, no. And they're like, that's bad. And we're like, yeah, that's just like not our mission. So think about what people actually spend money on today, which is not soil carbon measurement, and make sure you're solving that problem as well. The other thing I would encourage is just generally like spend 90% of your time in the soil science community and 5% of your time in each of the tech community and the, whatever the alternatives are, VC community, carbon markets community, because especially speaking as a non-technical founder, it is so easy to feel like, oh, look, free satellite data. Oh, look, Sergo, there's all this stuff out there. I'm sure I can AI, ML blockchain this into something meaningful. And like, any soil scientist will tell you, like, you probably can't. Like we've tried a lot of things. So I would just behoove folks to make sure they're spending their time with the folks that have been deepest in these technical considerations for longer.
If I may add anything very, very briefly, that I think Chris and Jenette brought great points, right? And a key thing is, if you're not a technical founder, find yourself someone also technical who can support you, right? Because this is a very, very technical area. But beyond that, you have to also think about, what do you want to prioritize at the end of the day? What is your goal? What is your mission? Like, do you think like Amazon and say, I want to prioritize the customer? Customer is always right, customer obsessed. In our world, being customer obsessed actually means prioritizing the people who are buying the credits, because they're actually the customers on the marketplace, if you think about it that way. On the other hand, there are many folks, of course, who are farmer obsessed and farmer focused. Well, all of these are different viewpoints, and you have to decide for yourself, and what you decide on is how you end up optimizing how your technology and your path forward is. There have been so many optimizations that we've done on Boomitra because of the vision that I set out of how this company is supposed to be. And someone coming up with a different vision of how things should be set out would have developed a completely different technology and different way of approaching different kinds of regions of deployment, everything different, right? So you're decide that for yourself, what do you want to do, and then stay focused. Obviously, with any entrepreneurship.
All right. Excellent. Thank you, everyone. Thank you, Aadith. Thank you, Chris. Thank you, Jenette. And thank you, Radhika, for your moderation for today. This is the end of our event. I shared a few links. One, if we didn't get to answer your question in the Q&A, I sent you the panelists and Radhika's emails. Feel free to ask them offline. Also, note that our next event is 2 weeks from today. We're going to be talking, instead of MRV and soils, MRV for DAC to mineralization. So we're going to have places like Climeworks, Carbon Cure, and 44.1 at that event. So should be a fun one. Finally, for, again, entrepreneurs in the audience and watching the recording, our AirMiners Launchpad 8-week program is accepting applications for its next batch until September 30th, until Friday, 2 days from now, 2 days from now, 2 days from now. So feel free to send your application in through the link that I supplied to you there, launchpad.airminers.org/apply. Otherwise, this is the end of our event, and I want to say thank you once again to our audience. We do this for you, and it's been a pleasure to host you today.